Hello everyone. My presentation today is an introduction of a parallel network community detection algorithm based on distance dynamics. I'm Tuiyuan Zhang. Those are the outlines of today's presentation. Now we start with background. With the rapid development of the internet in recent years, social network has been paid more attention in research. People have gradually found that social networks often contain modular network structure, which called community. Generally speaking, the features of community structure in a network can be summarized as following. The nodes of the same community are closely connected with each other, and the nodes of different community are sparsely connected. Network community structure can better describe the features of social network. The community research can be used as the basic research to support the research content of the higher level. Therefore, the research related to community is valuable and essential. Now we introduce some related works. Here is the development base of research of community detection. In 2002, Jivan and Newman proposed the CPM algorithm. In 2008, Blunder proposed the BGLL algorithm. In 2011, the Hangel proposed the matrix factorization based algorithm. In 2014, performance was proposed as a new evaluation criteria. QCA algorithm was proposed, which can complete network community detection in a more efficient way. The motivations of research are not only the popularity of community detection nowadays, but some iteration of existing methods, some of which will be introduced now. The rapid development and the wide application of internet led to the increasing amount of data and the growing size of network. There are many several version community detection algorithms based on modularity. The DC3D algorithm is not able to process large-scale network data, and in each iteration, it is complex to quantify the effects from edge and nodes using the local detection model. Therefore, the simple local computational model would be more appropriate than the complex local interaction model. Motivated by all those above, we proposed a novel parallel community detection algorithm called Pcdu algorithm based on distance dynamics. We first introduced some concepts related to parallel Pcdu algorithm for better understanding. Standing algorithm based on distance dynamics is proposed by Shaw in 2015, which first uses the Jacquard distance to calculate the initial distance between node U and V, where the Jacquard distance is defined as shown. In single DC3D method, there are three interaction patterns among nodes to simulate the distance dynamics. The distance of edge is respectively influenced by direct linked nodes, common neighbors, and inclusive neighbors. We describe the influence as DI, CI, EI respectively. Their calculation formulas are given. Building upon the above concepts, this paper proposes a unified model to describe the influence from direct linked nodes, common neighbors, and direct linked nodes in a more abstract way. For direct connection influence, considering edge E is given directly, neighbor edge U meets the original edges connecting with node U, and neighbor edge V means the original edge connecting with node V, and the original edges set is obtained by the numbers of direct neighbors. For common neighbors influence, neighbor edge U means the original edges connecting with node U, and neighbor edge V means the original edges connecting with node V. That edge distance can be obtained as the edge E is updated by using the distance value of those edges which construct the common neighbors. For external neighbors influence, the distances calculation can be divided into two stages. First, the update value of E is calculated through external neighbors of node U. When neighbor edge U misses the original edges connecting with node U. And the neighbor edge V is the two hop neighbors edges connecting with node V. Pcdu algorithm describes the specific idea of the parallel algorithm in a single network. The original graph is constructed by the user's input parameters. At this stage, the partition storage way is specified. First, we add edges between adding two hop neighbors with the property of original connected edge marked as 0, where the property of two hop neighbors edge are marked as 1. Next, the first allocation of the first allocation function is used to assign the initial distances to each edge. After that, the information of each edge is connected by function calculator, and the distance of connecting edge is sent to the two connected nodes to form a message taking nodes as a unit. The distances of the connected edges in the network are updated by using the other allocation function, and the distances of all edges are detected to record edges whose distance is not 0 or 1. One certain iteration ends. If there is no new message generated, there is our distance are stable at 0 or 1 and not changing. Community division begins to stabilize. At the end, we cut off our edges with distance of 1 and detect connected components. Then the final community division is obtained. Now, I'll show you the new NMI calculation method. In the calculation formula, we can see that the calculation of the double summation is needed. For the summing operation of the two dimensional matrix, we proposed another effective method to implement it. The NMI formulas operations are mostly centered on summation, including double summation, and the intercommutation of each summation is independent of each other, which makes a parallel commutation possible. Through the following experimental comparison to illustrate the advantages of our double summation algorithm compared with the method based on of two dimensional matrix calculation. The contrast algorithm is the NMI algorithm for the clustering modular in scikit to learn. For the clustering results of the different sizes, we count the calculation time of NMI. Now, I'll show you the experiment results. The amazing data set of the real-world network is used when the network size is small as the number of nodes and edges of the experimental data size are shown in table. When the network size increases, in order to avoid the effect of super a large degree of the covering nodes, we generate the artificial network by programmed based on LFR model with 10 meter and 20 meter levels. For the parallelization algorithm, the test cost usually is a good evaluation standard. When the network size is small, the computing time of algorithm is obviously less than that of the parallel algorithm. Since single algorithm uses a special data structure to store the distance of edges. At the same time, our operations are run on a stand-alone machine. It's noteworthy that in a theory of parallel computing, the growing rate of computational time should be sublinear. However, the experiment shows that the computation time of the 2000 level network is about 2.9 times of that the 10 meter level network. Next, I'll show you the conclusion parts. First, a novel parallel algorithm for community detection is proposed. It overcomes hardness to find small community and outliers. Second, the parallel programming design and the Spark platform make this method suitable to process a large-scale network. Next, a new and effective method is proposed based on the double summation to quickly calculate the NMI of it and as the embedded community structure in original graph. Finally, in the future, we can develop and improve Pcdu algorithm to make it applicable in the directed weighted graph and heterogeneous networks. Uh, Thank you for your listening.